Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo. Teleradyo, Teleradyo Marcelo.
Hello, Delpilarians, hello! Welcome to another fun and exciting learning with me, Mom Queenie, on this episode of Teleradyo Marcelo, ang telearalan ng bawat malulenyo. We are now in the 5th week of our 3rd quarter in this afternoon. I will assist you in having an hour of easy learning in statistics and probability. In this lesson, you will be able to apply the concepts of sampling distribution of the sample mean to solve real-life problems in different disciplines. Here are the objectives for today. At the end of this teleradyo session, you must be able to find the mean and variance of the sampling distribution of the sample mean and define the sampling distribution of the sample mean for normal population when the variance is known and unknown. So these most important learning competencies will be discussed in this session as you progress through your academic journey. So take pleasure in your success toward our goal. But before that, don't forget in this afternoon to bring your companion, Mr. Calculator. So now let's go over our previous lesson again. So the previous topic was about random sampling, parameter and statistic, and sampling distribution. Okay, so let us put your knowledge to the test. You will apply what you have learned in the previous lesson to the current lesson, which is about determining the mean and variance of the sampling distribution of sample means in this activity. So several ideas from the previous lesson apply directly to this lesson. You'll be able to connect those concepts and ideas as we go over the lesson this afternoon. So this activity will make use of an exciting word scramble game. So let's get started. For the first question, the blank distribution of sample means is frequency distribution of the sample means taken from a population. So I'll give you a few seconds to answer this one. To guess the word, type in the comment box your answers below. The blank distribution. Right. If your answer is sampling, then you are correct. For the next one, we have this. The blank of the sampling distribution of the sample means is a bar graph constructed by plotting the sample means along the horizontal axis and the problem along the vertical axis. What do you think is the word? Okay. So if your answer is histogram, then you are correct again. Okay, so who among you got the correct answers? Good job. For those who failed to answer correctly, don't worry, we still have 3 items left. Just stay focused and be determined to learn even after a number of failures. So let's have the third one. The blank of the sampling distribution of the sample means is equal to the mean of the population. So a few seconds for you to chat or to type your answers in the comment box. So it is the blank of the sampling distribution that's equal to the mean of the population. If your answer is mean, then you are correct. For the fourth one, we have standard blank of the mean is the standard deviation of the sampling distribution of the sample mean. So what is this standard blank of the mean, which is the sampling standard deviation of the sampling, right? If your answer is error, then you are correct. So this is the standard error, which is another term for standard deviation of the sampling, right? And then we have the fifth one. Mean is also called blank value. Okay, few seconds. What is the other term for the mean? Right. So if your answer is expected, then that's correct. So mean is also called expected value. Okay, so you did an excellent job, learners. Despite the pandemic, education must continue, and we applaud all your efforts in pushing through this school year and ensuring that it is both informative and productive. Your efforts are greatly appreciated. Since you've finished reflecting on and equipping yourself with the terms of the previous lesson, let us further put your knowledge to the test with this next problem. So we'll have another recap of the previous lesson. I have here a situation which goes like this. It is Monday. Harvey is very enthusiastic and challenged for his modular distance learning experience at week 5 in statistics and probability. His encounter with past quarters and modules justifies his excitement in learning more about the core subject. He chose the MDL, or the digital module scheme, because it is more practical to his condition. On the other hand, his mobile phone notified him that Module 5 of Statistics and Probability had been posted to their Facebook learning space, ready to be accessed and downloaded. Surprisingly, there is a problem with Harvey. He forgot his 5-digit smartphone passcode. All right, so that will be our goal for this review or this recap. We're going to guess, or we're going to try to know the 5-digit smartphone passcode of Harvey by having this activity. All right, so for this activity, you can use your notebook or a blank sheet of paper. Here is the list of codes for Harvey. So you can take down all this. So this is the, it stands for the 5-digit smartphone code of Harvey. All right. So we have here, we have to decode the passcode. So I hope you're done copying the table. Okay, so as we go through the concepts, you will be filling out the table provided. So we'll be filling out the numbers in the code part on the first row. Okay, so connect them to the appropriate number in the code table. So, all right, so I guess you're ready now. The first concept we have to recall is the variance and the standard deviation of ungrouped data using the given problem. All right, so let's have this given set of data where the random variable x is composed of 2, 5, 6, 9, 11, and 13. Okay, and then complete the corresponding table and compute for the variance and standard deviation. So this will go for the code 1 and 2. Okay, so we're going to construct a table out of this. So to answer the variance and standard deviation, we have first to have the column x squared. Okay, so we have here the column x and then the column x squared. The column x stands for the random variables, x squared. We're just going to square whatever is on the first column. So for example, we have here 2 squared. So that's 4. And then we also have here 5 squared. So that will be 25. All right. So the next one, I'll leave it to you. Okay, so I hope you can answer the rest. So 6 squared, 9 squared, 11 squared, and 13 squared. Okay. Okay. So there, I have here a timer. So I hope you're done once the timer has ended. Okay, so 6 squared is 36, 9 squared is 81, 11 squared is 121, and 13 squared is 169. Right. Okay, so if you're going to recall the formula for variance and standard deviation, we have to get the sum of the two columns. All right, so of course, the sum of this first column, 2 plus 5 plus 6 plus 9 plus 11 plus 13 is equal to 46. On the other hand, the sum for the column for x squared is equal to 436. Okay, so I hope you also added it correctly. Okay, and then let's have the formula for the variance. Formula for the variance is sigma squared is equal to summation of x squared divided by n minus summation of x over n quantity squared. All right. So we're going to get the sum for the second column first. So again, the sum for second column is 436. Sum for the first column is 46. So 436 over n minus 46 over n squared. Right? So there we have the summation. And then, so I will just wait for you to answer this. Anyway, our n is the number of observations, which is 6. All right, so I'll substitute 6 here. Okay, so I hope you're done entering it in the calculator. Okay, so the variance is, you can type down your answer in the comment box. So anyway, your math teachers are tuning in with us in this session. So I encourage everyone to participate. Okay, so here the answer is 125 over 9 or 13.899. So I just use 3 decimal places. Okay, so 13.899. So this goes for our code number 1. Okay, and then the standard deviation, as you all know, is the square root of the variance. So sigma is equal to square root of summation of x squared over n minus summation of x over n quantity squared. Okay, and then again, we substitute all the given. We have here 436 over 6 minus 46 over 6 squared. Okay, so what is your answer? Type down in the comment box your answers. Okay, so remember, effective learning in mathematics is through constant practice and application. So always participate. Okay, so we have here the symbol for standard deviation, sigma. So this one is equal to 5 times square root of 5 over 3. Or in decimal, this is going to be 3.727. So this is now our second code. All right. So now, in solving both the variance and standard deviation, we got 2 digits from Harvey's code. So we got 13.899 for the first meaning for 1 and 3.727 for the second one. All right, so we have here these 2 codes now. So we still have 3 left. Okay, so did you get it right? As we decode this passcode, we can review important concepts that we will be using in our next topic. Okay, so next, moving on, do you recall how to calculate the mean or the expected value? So that's what are we going to do next. Okay, so the mean and expected value, or E of x. So we will use this given problem to recall the idea about mean and probability distribution. So find the mean and or expected value of the given probability distribution. So again, the mean is equal to the summation of x times p of x, wherein we're just going to multiply the random variable with the probabilities, with their corresponding probability. So it's going to be x times p of x. All right, so how do we do that? So we have 0 times 0.1. So that's going to be 0. 2 times 0.150 is equal to 0.3. Or we can also do it 3 decimal places. So it will be uniform. All right. And then I'll leave the others for you. All right. So you're just going to multiply the first column with the second column. So that's 4 times 0.2, 5 times 0.14, 6 times 0.15, and so on. All right. So it will be better if you have your calculators with you. Okay. So if your answers are like this, 0.8, 0.7, 0.9, 0.72, 0.33, 0.75, 0.7, 0.48, and 0.18, then your answers are correct. All right. Okay, so we found now the third column. What are we going to do next is to get the sum of this third column. All right, so if we compute the sum, so I'll wait for you to add this. So we have 0 plus 0.3, and then type in your answer in the comment box. The sum for x times p of x. Take note, your math teachers, your stat teachers are watching with you. All right, so they know who are answering. Okay, so 0 plus 0.3 plus 0.8 plus 0.7 plus 0.9 plus 0.33 plus 0.75 plus 0.7 plus 0.48 plus 0.18 is actually equal to 5.86. All right, so if you commented down 5.86, then you are also correct. All right. So therefore, we have now the third code, which is 5.86. So that will be our expected value or mean. Okay. So here, so we have the code table. We're done with 1 and 2. For the number 3, we have 5.86. Okay, so I need you to remember variance and standard deviation for the final concept we need to go over. So were you able to grasp the significance of those terms in the earlier discussions? Remembering the formula is secondary to understanding the concept. Visit your Google Classrooms for learning materials and enrichment activities to better understand our lessons. You can also watch previous statistics and probability video lessons on our school's official Facebook and YouTube page. All right. The last problem involves computing for the variance and standard deviation of a given probability distribution. Okay, so look at the given distribution. Okay, using our example, compute for the other given values of x. All right, so I will be giving you, but before that, I will do first the column x squared times p of x. So again, we are computing for x squared times p of x because we're looking for the variance and standard deviation. So this means we have to multiply the second and the third column. Okay, so 0 times 0.1, it's going to be 0. 4 times 0.15 is 0.6 or 0.600, just to maintain the 3 decimal places. So I'll leave the rest for you. So you're just going to multiply x squared, the column x squared times p of x. Okay. All right. Okay, so if your answers are 12.8, 7.5, 32.4, and so on, so you can check it individually, all right, to know if you answered it correctly. Okay, and then after that, you just have to get the sum of this column. Get the sum of the last column, the fourth column, x squared times p of x. Okay, type in your answer in the comment box. All right, so thank you for your active participation. We have here 637.060. Right, so that is our summation of x squared times P of X. Okay, and then as you can remember earlier, we have the mean, which is the expected value, given in the code table 5.86. So we will be needing that in our variance, because the formula for variance again is sigma squared is equal to summation of x squared times P of X. This is the alternative formula we are using, minus mu squared. Okay, so let's substitute the given. It's going to be 637.060 minus 5.86 or 860 squared. Okay, so I'll give you a short time so that you can enter it in your calculator and answer it. Okay, what is our variance for this table, for this given? Type in your answers in the comment box. Okay, so if your answer is 602.72, then your answer is correct. All right, so this is going to be the fourth code. All right, so that's going to be number 4. And finally, we have the standard deviation, which is again the square root. So we have sigma is equal to square root of summation of x squared times P of X minus mu squared. And then we substitute the given, it's going to be square root of 637.06 minus 5.86 squared. Okay, so again, type in your answer in the comment box. Okay, so the answer here is 24.550. And we have now the fifth code. All right, so now it's time to check our code table to see if we can now complete the code. All right, so remember the answer we have here, 602.72 for the fourth one, 24.55 on the fifth one. Okay, so there we have 602 on the first given, and then 24.55 on the middle one, on the third one. Okay, so that's going to be the code 4 and 5. All right, so we've got the correct answers for our variance and standard deviation. The last missing digits in the passcode were filled up. So congratulations, you access Harvey's smartphone. Now, Module 5 of the subject Statistics and Probability can be made available and downloaded. Okay, for today's topic, we will be focusing on finding the mean and the variance of the sampling distribution of the sample means. But first, let us define some important terms in our discussion. For example, we have the sampling distribution. So are you guys familiar with the term sampling distribution? What do you think is it all about? So let's find out. So for the first one, sampling distribution is simply the probability distribution that describes the probability for each mean of all samples with sample size n. All right? So it means it is listed here the possible outcomes if you have a given sample size n. All right? That you're going to get out from a given population. Okay, so the sampling distribution of the sample means taken with replacement from a population n with population mean mu and variance sigma squared will approach a normal curve according to the central limit theorem. Okay, so we'll go deeper into this later once we have had the formula, which are this. So the mean for the sampling distribution is denoted as mu sub x bar. Okay, mu sub x bar is equal to summation of x bar over n, wherein x bar is the sample mean and n is the total number of observations. So it's like the same. It's almost the same with finding the mean of the population that we had earlier on our recap. But the difference is instead of the random variables, we're actually getting the sum of the sample means that we can obtain from each of the data in the sampling distribution. Okay, so instead of x, we have x bar. Okay, alternative formula. We have mu sub x bar equals summation of x bar times the probability for each sample mean, or p sub x bar. Okay, so next we have the variance, which is again the same with the variance of the previous one, but instead of random variable x, we'll be using the sample mean symbol x bar. So sigma squared sub x bar is equal to summation of x bar minus mu quantity squared over n. All right, wherein n is the total number of observation. The mu sub x bar is again mean of the sampling. X bar is the sample mean, and sigma squared is the variance itself. Finally, we have the standard deviation, which is the square root of the variance. So sigma sub x bar is equal to square root of summation of x bar minus mu quantity squared over n. Okay, so it has the same legend with the first that we had, except for it has a square root, a radical. Okay, so we'll use examples to apply and deepen your understanding of the mean, variance, and standard deviation of the sampling distribution of sample means that I've discussed. So let's try this. Let's have this example. The following table gives the sum of tutorial rate of 6 teachers in Central Luzon per month. Okay, so we have here the table for the rates of the 6 teachers. So our table depicts the tutorial rate for the teachers. Teacher A receives 8,000, while teacher B receives 4,000 more than teacher A. Then teacher C has a rate of 16,000, while teacher D and E have rates of 20,000 and 24,000 pesos respectively. And teacher F, on the other hand, is paid the highest rate of 28,000. So suppose the random variables or the random samples of size 4 are taken from this population of 6 teachers. Then we'll do the following tasks. First is solve for the mean of the population mu. Second is solve for the mean of the sampling. Third is compare the population mean and the mean of the sampling, or in other words, compare the answer in number 1 and number 2. And then we have step 4 up to 6. So step 4, solve for the variance and standard deviation of the population. Next is solve for the variance and standard deviation of the sampling distribution, and then compare. All right, so the 6th step is again compare. Okay, so the first task is to solve for the population mean. Okay, so to solve for the population mean, we have again the formula mu. Okay, mu is equal to summation of x over n. So as you can remember the data that we have earlier, the amount in thousands of the rates of the tutors are 8 plus 12 plus 16, 20 plus 24 plus 28. So we just get the mean of this divided by the number of observations, which is 6. Okay, so 8 plus 2 plus 16 plus 20 plus 24 plus 28 is equal to 108 over 6, which is also equal to 18. All right, therefore we have our population mean of the tutorial rates of the selected teachers in Central Luzon, which is 18,000 in average per month. Okay, so our next task is to solve for the mean. Okay, solve for the mean of the sampling distribution of the sample mean. So we'll solve this using the following steps. So we're going to undergo these steps. Okay, the first one is identify first the possible samples of size n and compute for their individual means. So, and then after that, we will construct the sampling distribution table for the sample means and multiply the sample means to their probabilities. So for the mean of the sampling of the sample means by using the formula mu sub x bar is equal to summation of x bar times p of x. Okay, so this is the same formula that we had a while ago. So let's have the first one. Okay, for the first step, we'll identify the possible samples of size 4 and compute for their individual means. Okay, so let's organize everything into a table. Okay, so again, I will list down the given. We have 8, 12, 16, 20, 24, and 28. So we're just going to get 4 samples out of this. So meaning we're going to have different combinations. Okay, for example, first combination to be 8, 12, 16, and 20. And then second combination could be 8, 12, 16, 24. Third combination could be 8, 12, 16, and 28. Right? And then on the next column, we're just going to get the sample mean of all of this. So 8 plus 12 plus 16 plus 20 is actually divided by 4 is actually equal to 14. And then 8, 12, 16 plus 24 divided by 4 is equal to 15. And for the last one, we have 8 plus 12 plus 16 plus 28 all over 4. That's equal to 16. All right, so I'll give you a few seconds again for you to complete the table. Okay, so you can find or you can have your own way of listing down all the possible samples you can obtain from this. As long as you're not going to repeat any of the possible sample or everything will go wrong already at this point. Okay, so be very, very careful with identifying the possible samples. Okay, so if your answers are this, okay, 8, 12, 20, 24, 8, 12, 20, 28, there, and so on. Okay, you can just check it one by one if you got it correctly. Okay, so, and also double check that none of this have repeated. Okay, because this is choosing the sample without replacement, meaning you cannot repeat any of this. Okay, so sample means. So for the sample means, we have here this x bar, values of x bar. Okay, so again, we are looking for their individual means, and then we're done with that. For our second step, we need to construct the sampling distribution. Okay, so sampling distribution, meaning we're going to focus on the sample means on the second column. So we're going to construct a separate table wherein we're going to list down the sample means x bar. We will treat that as our previous random variables. Okay, so that's going to be 14 is the lowest value, and then 22 is the highest. Okay, and then we're going to write down the frequency. How often did each of the sample means occur? Okay, so we have here constructing the sampling distribution. So that's 14 to 22. All right, so for example, in the given table earlier, the 14 occurred once only. So that's the frequency. 15 is only once. 15 occurred only once. 16 occurred twice. So if you want to check it, we have here, there. So that's 14, that's 15. 16 we have twice, so it occurred twice. And then there, it's like you're going to tally, all right, the frequencies for each sample mean. Okay, and then the rest is this, 2, 3, 2, 2, 1, 1. Okay, and then we get the sum of this so that we can proceed with the next column, which is the probability. So the total of this, 1 plus 1 plus 2 plus 2 plus 3 plus 2 plus 2 plus 1 plus 1 is equal to 15. Okay, So anyway, even if I'm discussing, you can still type in your answer in the comment box so that we'll know if you're getting the point or not. Okay, so probability or P of X bar. Okay, so we're just going to use 15 as our common denominator, and then whatever is the number on the frequency, that will be our numerator. So it's going to be 1 over 15, 1 over 15, 2 over 15, and then the rest are this. Okay, and then finally, let's add. So it's going to be a total of 15 over 15 because this is a discrete probability distribution. So this will be equal to 1. Okay, and then we have the last column, which is x times p of x, or x bar times p of x bar. Okay, so this is going to be 1 times 115. 14 times 1 over 15. The first column times the third column. We have 14 over 15. And then 15 times 1 over 15 is 15 over 15. 16 times 2 over 15 is 32 over 15. Okay? And then we have the rest, like this. Finally, we get the sum of the x bar times p of x bar, so that we're done with the expected value or the mean of the sampling. So this is going to be 270 over 15, which is also equal to 80. Okay. So now we can proceed with solving the mean. Okay, so the mean of the sampling, distribution of the sample means using this formula, meaning we're going to sum up the last column. So our answer is 18. So therefore, the mean for the population mean is 18, and then okay. So we have here mu sub x bar is equal to 18 because of what we have here. Okay, so the third task is to compare. Okay, so the third task is we're going to compare the answer with population mean and the mean of the sampling. So what have you observed? Okay, you can type in the comment box, what have you observed from our answer in the first task and in the second task? If you think that the population mean is equal to the mean of the sampling, then again, you are correct. All right, so meaning whatever is the population mean, that will always be equal to the mean of the sampling distribution of means. Okay, so now let's proceed with the fourth task. So this requires the value of the variance and the standard deviation of the population. So we'll solve for the variance and standard deviation. Okay, let's first complete our table of values. Let's have first the population variance and standard deviation. Okay, so here are the values. We have x and then the column x squared. So we have here 8. So 8 squared is equal to 64. 12 squared is 144. 16 squared is 256. And then the rest will be 20 squared is 400, 24 squared is 576, 28 squared is 784. Okay, and then we get the sum of both columns. Okay, type in the comment box below what is the sum for the column for the random variable x, and also the sum for the square of that. Okay, so type in your answer in the comment box. Okay, if your answer here on the first column is 108, so that's summation of x, 108, then you are correct. And then also if your answer here is summation of x squared is 2,224, then you are also correct. Okay, so therefore, we're ready to solve for the variance. Okay, so the variance again have the formula sigma squared is equal to summation of x squared over n minus summation of x over n quantity squared. So we have summation of x squared is 2,224 over n is the number of observations, so that's 6 minus summation of x is 108 over 6 squared. Okay, so I'll give you a few minutes or rather a few seconds to answer this. What do you think is the population variance? Anyway, you can enter it directly to calculator to solve faster. Okay, so you can round off your answer to 2 decimal places. That will do. Okay, so if your answer is 4.67, then you are again correct. Okay, so the variance is 4.67. Okay, and then standard deviation is the square root of that. So it's going to be sigma is equal to square root of 2224 over 6 minus 108 over 6 squared. Okay, what is your answer? Okay, if your answer is 6.83, then you are correct. So therefore, the variance for the population is 4.67 and the standard deviation is 6.83. For our fifth task, we'll be solving the variance and standard deviation of the sampling distribution of the sample means. So let us consider the following steps. Okay, so remember the formula that was shown to you at the start of our formal discussion. So we'll use those to compute the variance and standard deviation of the sample means. Okay, utilize this formula. Okay, so I hope you have taken it down. Okay, now let us construct the sampling distribution table for the sample means, square the sample mean, and then multiply the result to the probability. So we're going to have additional column for the sampling distribution table that we had a while ago. Okay, so construct the sampling. Okay, we have here the sample mean that we have 14 to 22, and then we're going to square that. So 14 squared is 196. 15 squared is 225. Right? And also 16 squared is equal to 256. There. Okay, so you can do the rest for 17 squared up to 22 squared. You can compare your answers with this, the one I have on the table. All right. So, and then we get the sum. Okay, so since we're already here, we get the sum of this. Okay, the total for x bar squared is equal to 2,976. Okay, and then for the probability p of x, so that stays as is. And then we have the column x squared times p of x. So meaning we're going to multiply the first with the second column. So it's going to be 196 over 15. And then 225 over 15. And then 256 times 2 is 512 over 15. And so on. Okay. There. And then again, since we're solving for the variance, we get the sum of x squared times p of x. Okay, so the sum of this is 4,930 divided by 15, or in decimal, that's going to be 328.67. Right, so we just rounded off. Okay, so apply what we have done to the rest of the sample means. Okay, so here are the computed values that we have now. Now we're ready to solve for the variance and standard deviation. Okay, solve for the variance and standard deviation. So the variance, again, formula is summation of x squared times p of x bar minus mu sub x bar. Okay, and as you all know, we have the given for the variance. Okay, so the one that we sum up earlier is equal to 328.67. And then minus the mu, the population mean, which is also equal to the mean of the sampling. So this is equal to 18 squared. There. Okay, and then just execute the operation. This will bring us 4.67. So that's the variance. Okay. Okay, now let's have the standard deviation. So for the standard deviation, we have the same given, but we have a radical sign. So 328.67 minus 18 squared. Okay, so if your answer is 2.16, then you are also correct. Right, let's box our final answers. Okay, 2.16. Finally, our final task is to compare the standard deviation of the population and the sampling distribution of the sample mean. Okay, so we're just going to compare the two. Okay, so as you can remember, the standard deviation of population earlier is equal to 6.83. And then the standard deviation for the sample mean is 2.16. So meaning, what we can infer here is that the standard deviation of the population is not equal with the standard deviation of the sampling. All right, it's just the mean or the expected values that are equal when it comes to population and the sampling distribution. But for the variance and standard deviation, of course, they are not equal. Okay, so let's put into practice what you have learned about the sample mean. Have you followed the course of our discussion for this afternoon? This video lesson is always available on our school's official Facebook and YouTube pages. Now that we've improved your mathematical skills with the concepts of sampling distribution of the sample means, it's time for you to do some independent work at home. So we have here a given problem, and you can take a screenshot of this so that you can answer it at home. All right, that's the first one. That's the situation, and then this is the given data. Okay, so take a screenshot, and then this is what are you going to do with this data. So you're just going to do what we have done from 1 to 6, from step 1 to step 6. Right? So again, what we did is we solved for the mean of the population, solved for the mean of the sampling, and then we compared. And then after that, we solved for the variance and standard deviation of the population, and then variance of the standard deviation, or variance and the standard deviation of the sampling, and then compare it again. Okay, so that concludes our discussion for the afternoon. So use your free time at home to better understand and become acquainted with the topic. So as well as our method for calculating the mean, variance, and standard deviation, practice is key to achieving success in mathematics. Visit your respective Google Classrooms for instructional materials and other activities to enhance your math skills. Always make it a habit to tune in to Teleradio Marcelo to satisfy your day with fun and exciting educational videos. Again, this is Mom Queenie. See you on our next broadcast. Bye.
Makinig, manood, nasa teleradyo. Makinig, manood, nasa teleradyo. Teleradyo, teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo. Teleradyo, teleradyo Marcelo.